Or it should be. It's taking its time to, like, go live. Okay, I think this is working then. Let's make sure that you can see me.
Okay, I'm waiting.
Hey, and we already have 3 concurrent viewers.
Okay, well, I can see you.
Okay, and you can hear me?
I can. Yeah, I have you muted on YouTube though because of the delay.
Well, sure. I just want to make sure that OBS is actually getting my audio properly. Oh, but I can see that it is actually.
Yes. Yes, you're fine.
Okay.
So, here we are.
All right, so...
Hi, everybody.
Hey, yes, we are here for our third notional pipe rigging stream. And last time, we were talking about fingers and contour deformation and a whole bunch of other stuff. And this time, I think we are going to take a look at rigging the lapels, probably, and some considerations around that. And probably doing some pose space deformation and talking about how that interacts with contour. But I will also note, one of the things that we've talked about a lot in terms of these streams is making them a bit community driven. Like the viewers can call out like what they want to know. So while I certainly have like kind of a plan for how to proceed from here, you guys, you 3 concurrent viewers we have right now, who I'm not sure who it is because it doesn't tell me that information, should feel free to ask questions about what I'm talking about or suggest entirely alternate topics if you want. And, I don't promise to necessarily switch to an alternate topic, but I would definitely consider it. Anyway, before I start any of that, I'm just going to go zero out this stuff. So, yeah, I think maybe the thing to address first, because I was thinking, like, I'd go on to rig some of the sort of peripheral elements of the character. You know what I should actually do before I do anything else, is that I should move this rigging from this hand over to the other one, because otherwise that's not going to work particularly well. And actually, I should check here, because now that I'm thinking about it, I think we kind of left this bit undone, right? Or, like, we didn't even really do the thumb. And, we actually have a whole bunch of stuff that still needs to be done on the hands to make them, like, be viable hands. Right, like the absence of a thumb being the most obvious issue. Everything else, like, deformation-wise, I think this is all fine. But, that's not a particularly exciting thing. You're just going to see me, like, draw some more joints and stuff. So maybe I will actually proceed to talking a bit about PSDs. Because it's sort of a more interesting topic, and then we can sort of jump back to the hands. Because it is something that I've been thinking a bit, we haven't really addressed yet, which is we have done a little bit of this stuff with the body where we're layering some of this stuff on top of contour deformation. But the question of how you do that with PSDs is actually a pretty significant one in terms of being able to get like clear control and art directable control over shapes. Because what contour does, and I've touched about this on this a little bit in the previous streams, but I'm just going to sort of reset the assumptions here because I don't really know who's watching. Maybe it's people who weren't there for the previous streams. Contour tends to produce very nice deformation entirely by default. You don't generally need to use PSDs or weight painting, which you don't even need to use internally to a spline. This is all one influence. And therefore, for the most part, just to get something to look okay, you don't need PSDs or other kinds of layered deformation. However, you certainly might like to use them for art directability. Because while contour will give you like general high-level control over the way joints behave, which is, really, really nice. Like I can be like, how sharp is this bend and stuff. There are plenty of circumstances where you need to be very, very precise about how your stuff appears. And one of the goals that we had was we want to make sure that it's possible to use it with PSDs. I see a question. This is from Ryan Craig. I've been using your tools for a while now, since the face machine, even, and was wondering if you think auto riggers or TSM3 are all going to be dead soon. So, in the near future, probably not, but I think that they should be. So I will take, in answer to this question, I will take a brief break from talking about VSDs to rant for a second about auto riggers, because I do really actually think like auto rigging is an idea whose time has passed, and it was always a questionable idea. It's just that it wasn't necessarily obvious that it was in the context of rigging as it exists, right? As opposed to sort of the theoretical concepts that underlie it. And the problem with auto rigging is that, as I've sort of mentioned, rigs are programs, right? Rigging is programming fundamentally, whether or not you're writing code. And an auto rigger is therefore a program that, in a sense, you could say compiles to a rig. Like, it generates this other program from itself, which, in theory, is not necessarily a bad thing. I mean, programmers have, compiled one programming language into another in various contexts, in various ways, and it's not necessarily wrong. But the problem that we tend to face with doing this in the context of rigging is that it's very, very difficult to fully define your rig beforehand in your sort of rig description or whatever your auto rigging is working from. So what tends to happen is that people generate a character or whatever using their auto rigger, and then they suddenly need to do something different, something unusual with it. And what they end up doing, because this is sort of the immediate expedient thing that will solve your problem in production that you really need to solve, is that they don't go and edit the rig description or create a new rig module or any of the things you might need to do with your auto rigger. What they do is that they just go into the scene and they screw around with the rig until it does what they need. And the problem with this, of course, is it makes it impossible to rebuild the rig. And like when we wrote TSM3, we had, a whole system for rebuilding rigs. But one of the rules about it was if you go modify the rig, you're obviously not going to get your modifications. There's not a way around that, right? So the problem here is that we really have two different, in a sense, sources of truth, to use, a term that, Tagore introduced me to that, I think is very common among programmers, right? You have two sources of truth. You've got your rig description or whatever the auto rigger is using, and you've got your actual rig, which is also a program, and which one of them is actually the source of truth? Well, it ends up being the actual rig is what it ends up being, which means that your auto rigger becomes essentially useless after a while, right? Like, depending on what it is you're accomplishing. It's only used for generating some stuff, which by itself is fine. Like, I write a lot, and you've seen me do this elsewhere on the stream, anybody who's been watching. I write a lot of ad hoc Python to generate myself rigging nodes. The difference is, when I'm writing ad hoc Python to try to generate some stuff, at no point do I think that there's a higher level concept associated with that, right? I'm not engineering a system to generate rigs. I'm just writing some code that generates me some nodes. And so that's fine, because I'm never going to push it back. Like, that's not even relevant. The problem with auto rigging is just that there isn't, and I've never encountered a scenario outside of like maybe large studios where you might actually have the option of saying like, yeah, there's going to be like, we are always going to do things purely through the auto rigger. We're always going to do things with rig modules. And even if that's painful, like, we're just making that a rule. And like, if you do that, sure, maybe it works out fine. But in my experience, that hardly ever actually happens in the kinds of productions that I've been involved with. So my feeling is that auto rigging is a troublesome concept, and that essentially it arises from the fact that the actual programming language, as it were, of rigging, which is actually the node graph, is the actual programming language of rigging, and it arises from the fact that the program that's a terrible programming language, right? Like, it arises from the fact that the kinds of abstraction that you would and higher level concepts that you would use in a programming language, right, that you'd want to be able to use, the ability to like basically box up behavior, say, in a function where you're like, well, this is how an arm behaves, and this function defines what that is, and I'm just going to use inputs and outputs. I'm going to give it the data it needs to calculate what the arm should be, and it's going to give me back the arm's actual behavior, right? And that kind of thing. Node graphs, unless you really, really, really go out of your way to try to impose some structure on it in a way that Maya really won't help you with, node graphs are just this big old ball of nodes with like a million connections between nodes, and there's no real structure to help you deal with all of that complexity. And so auto rigging arose because there needed to be some kind of structure on top of it. And because people were just tired of trying to make stuff by hand. But I think it's actually a very destructive concept. Like I think that auto rigging is really questionable as an approach. And I know I've sort of repeated myself a bunch during this rant. Let's see if I can get to the point a little more quickly. What I think I would much rather see is, in part, the kind of thing that we are doing with Contour, where it's like, well, a whole lot of the behavior that's sort of inherent to Contour is the behavior you always want in your rig, and therefore you're not actually that's your rigging primitive. Like this kind of goes back to this idea of like splines and surfaces instead of joints as your like underlying primitive. If you find a primitive that fits things, you no longer need this level of complexity that tends to necessitate a lot of auto rigging exists to do. I mean, obviously, like even basic things like being able to do decent twist, where you've got a bunch of joints and you've got a bunch of joints down your arm and they're twisting. Like even this basic behavior is something your auto rigger has to explicitly create. So what I'd rather see is a combination of finding the right primitive and perhaps some sort of, what people sometimes call like componentized rigging, similar to what Raphael Fragapane, and again, if he's watching this, I apologize if I'm mispronouncing his name, has advocated for, where you have units of rigging. You're essentially taking the Maya node graph and you are imposing on it the kind of structure that you'd actually want in a real programming language, even though that's not really something that the node graph does naturally. I mean, there are assets. There's this sort of Maya thing where you can sort of containerize nodes and like put them in this container with explicit inputs and outputs, but I've always had a very difficult time using them because honestly they don't seem to be a very well supported aspect of Maya. Like the UI and the interface for controlling them in commands is just very awkward, and so when I've done stuff like that, I've ended up kind of rolling my own. But that's ultimately like to answer your question. And I realize that I have, done quite a bit of, ranting at this point where, perhaps it's been a little bit not entirely to the point, but like, I don't know. I don't have great control over that. I do not think that auto riggers are going to stand the test of time. I think they are going to be replaced by something that acts more like an actual programming language. To answer another, so Ryan Craig has now also asked, so you don't have much control over where the joints go. Why bigger studios prefer tools like Contour instead? Yeah, I'm not quite sure that I'm parsing exactly what you're commenting on or asking there, so maybe a clarification would be useful. But I do think that essentially, yeah, and I mean, a lot of studios, of course, have implemented other methods of dealing with this. And like another example is control rig in UE. I don't have a lot of experience with control rig, but from what I have seen of it, and I'm just starting to like take a look at it and get a better understanding of it. One of the new features, for instance, is like basically have a blueprint function that acts as a piece of your rig, and that's exactly what you might call componentized rigging or like containerized rigging or like the various sort of ways you'd look at that. That's exactly what that's for. It's trying to section up the graph in nice, well-defined, abstracted ways that you can reason about easily. And that comes much more naturally to a framework like blueprints, even though they are, they're still they're still a visual programming language, right? But they're a much more well-defined visual programming language that allows you to, that it is intended to be used as an actual programming language, even though you're not actually writing any code. So it has a lot of the same concepts and a lot of the same ways of abstracting stuff and making things easier to reason about that you would use in an actual programming language. And that's where I see rigging going, and I'm very pleased to see Epic sort of embracing that approach. Like I said, I don't have a lot of experience with control rig. Like, there's a lot I don't know about it, but certainly from what I've looked at, it sure looks like that's the direction they're trying to go with that, and I'm very pleased by it because I do think it'll make just like, so it is. I'm one of the things that I will mention, and I can't really mention any details about what I am doing there, but I am working right now for the Third Floor. A company that is well known for pre-visualization. If you've seen a Marvel movie, you've probably seen their work. And I'm not doing the previs, and I can't really talk about what I am doing, but I will say that I have done some stuff recently where I've had a chance to start with a bit of a fresh slate with some rigging stuff, and the degree to which it has been easier to deal with because I'm trying to put these ideas into practice has been really notable. Like, there is stuff that I think, had I been attempting to write an auto rigger, would have taken me like a couple of weeks to accomplish. That when approaching things in a more componentized fashion, sometimes only takes like days. Like the difference, and you know, and contour plays into that really well too, right? The difference is stark. Part of the reason why rigging is so painful is that rigging technique is pathological, actually. And that's not nobody's fault. I mean, obviously we've done a tremendous amount of auto rigging stuff, like TSM and everything. I'm not saying like people were idiots to do things this way by any means. It's that rigging evolved in a really bizarre fashion, and people did the best they could with the bizarreness of rigging, right? And trying to like take this thing and layer something on top that could potentially work. Yeah.
So Raph, I mean, I do wonder though. A lot of this is incidental to some of that bizarreness of how rigging works, and it does seem to me because auto rigging, like as a larger concept, seems to me like a pretty good concept. It's just the tools don't. There's a combination of things that make it not work very well, but I wonder if those things are fixable. And you know, this isn't a programming stream, so I won't talk too much about it. But you know, you talk about writing programs that generate programs, and there's a lot of different ways programmers do that, ranging from, you know, well, compilers, all compilers in one sense or another are translate one language to another, but also there are differences in how effective those things are. For instance, if you're programming in C, which, you know, for instance, a lot of Contour is written in, you have the C preprocessor, but it's a very blunt tool, and so you don't want to do too much with the C preprocessor. If your C preprocessor is getting if your preprocessor stuff is getting out of hand, it's not a good thing. But on the other hand, as you know, I also do a fair bit of Lisp programming. Mm-hmm. And so macros are another way. I mean, what macros are doing is generating code at, I mean, essentially compile time. Technically speaking, we tend to talk about macro expansion time. And that's a really useful and powerful thing. You do have to be careful with how you use it. And part of what that enables that is that it is bidirectional, right? In the sense that you're not locked into it. You can go change your macro. And I think part of the problem is that you if you've made other changes, you sort of lose them. But I think that with a better system, that's not necessarily the case, right? I mean, I could see things going more in the direction of something sort of like auto riggers, if, you know, because obviously this stuff is going to evolve over time and get better, right? We certainly hope so.
Right.
At least, right?
No, I mean, it's absolutely true that the idea of having something like a macro is not bad. Like quite the opposite, actually. Like, that could be extremely helpful. But I think it has to do with the manipulability of what you're compiling into. And like, this huge issue with auto rig tools is that because the tools end up being complex, and just throwing a node into a rig is relatively easy, you end up with this situation. It's like just to use like a crazy analogy, right? You know, like, so one of the things that we do, you know, with a variety of things, we do this in Contour or stuff like that, is that we'll use a tool called Nuitka to compile some Python code that we've written into, like, well, it becomes a PYD, but it's basically being compiled into C and then compiled from there, right? But this would be the equivalent of, I think, if you tried to do that, but then you expected to actually be able to edit the C in some way. And so it's like, if you're writing with a macro, like, you don't expect, like that's something that's going to be processed, like, every time you, well, I mean, like, whatever your way of dealing with your code is, compiling or whatever. It's not something where you expect it to output something that you then edit directly, I don't think. But maybe I'm wrong. Maybe there are some cases where you do that.
There are analogies to that in programming, and, you know, something that was, for instance, kind of annoying, especially if you look back at like the way that Microsoft expected you to do Windows GUI programming about 20 years ago, say, using MFC. One of the things you would tend to do is there was so much boilerplate associated with it. You would start a Visual Studio project and it would generate you this huge mass of code that you were supposed to go then put your own code into little bits of that program, right? And it
I
was all
see.
this surrounding stuff. But then there would be times when you probably would want to actually like change some stuff in all this boilerplate and generate it for you. And that's a terrible approach. And I think that approach is actually pretty analogous to
Yeah, that's
how
very
rigging works,
analogous.
right? Or, for instance, I mean, as I said, all compilers really, right? Even a C compiler is compiling to some programming language, right?
Sure.
It could be going to assembler, which is then being compiled to machine code, or it could be going straight, down into machine code. And right, usually you don't want to try to edit the artifacts of stuff that you've done that way.
Right. Well,
But rigging really is programming, as you've said. And so I think that there are probably analogies within rigging. That is to say, you probably could have a system that was much more analogous to how this works. So that, I mean, if you were writing C and compiling it to machine code, you never go down to the machine code level and directly edit that. I mean, at the most, you might analyze. This is true in Common Lisp, actually, where sometimes when you need performance, I mean, one of the nice things I think about some Common Lisp implementations I've worked with is you can write a function in Lisp and then ask it to right there in your REPL, you can ask it, by the way, what machine code did this compile into? You can take a look at it. But you're not going to, and see, oh, okay, is this doing something smart about this? Do I need to, change the code a little bit so that the compiler does something a little bit
sure.
smarter and gets somewhat better performance? But it's not like you're going and editing that. You're changing the representation that is your primary representation.
Right, exactly. And so the analogy to that with rigging would be, well, you have if you had an auto rig system, it generated rig stuff, you could go take a look at the actual rigging it generates and like poke around at it and see if it's doing what you want. I mean, in some ways, that's the ideal, right? That's sort of the idea that a lot of people have had when they've written auto rig systems, was like, you're never going to edit stuff directly in the Maya scene. It's just that in most circumstances, in my experience, this has never actually come to pass. Like that's never how it's actually happened. I'm not saying never. Like, I'm sure it has happened somewhere, probably in a large studio with a very well-developed system.
Mm-hmm. Well, you need something that gives you, first of all, the power. And one of the things to know about, say, the difference between the C preprocessor and Lisp macros is that Lisp macros are Turing complete, right? Mm-hmm. Whereas the C preprocessor is very much not Turing complete. And it's a pretty convenient way of generating code. I mean, technically speaking, C++, like templates, if you do template metaprogramming, are also Turing complete, but nobody wants, I mean, you don't really want to use them as a code generation tool.
Yeah.
But macros work very well for that. So, I mean, that's right. Part of it. You have something that is powerful enough, and also you want it to be easier, right? The reason that you're writing, say, C or Python instead of writing directly in machine code is that it's actually a lot easier. It's something you don't want to be.
Well, sure, exactly. Well,
right.
And ironically,
you need something that's easier that way. And ironically, they often aren't, or at least for certain things. Either you lack the power, or it's not easier for this particular task. But I mean, it strikes me that this is sort of an implementation detail, although admittedly one that's very hard to actually do anything about. But in the long run, I kind of wonder if something like that might actually really be the future of rigging.
Oh yeah, well, I mean, here's I think what it comes down to. I mean, you look at the way that control rig works, and again, I'm going to say I have never tried to really do anything with control rig. I'm going off like I've poked around at it and sort of like tried to get a sense of how it behaves. I haven't had the opportunity to do anything real with it, so like to take anything I say here with a grain of salt. But it really looks to me like control rig really is being, and this follows UE's general philosophy, right? Control rig is treating rigging as programming, because doing visual programming is just an extremely normal thing to do in Unreal anyway. And that could include, now I don't know if you could do them in control rig, but blueprints certainly have macros, right? All of the type, I mean, a lot of other sort of tools that you might expect in a programming language. I mean, they're not as full featured by any means as, really most programming languages that are widely used, right? But they do have a lot of tools. And that's exactly the kind of thing that you want in a rigging development toolkit, right? You want the ability to be like, yeah, we can define all of this behavior, potentially including things like macros and functions and other things that we can use to, cut down, to express the concept that we want to express in a succinct fashion, right? But at no point in that system are you generating a thing that you're then going to go poke at and edit manually. Right, you are dealing with it on the level of code, right? On the level of your blueprint, and that's what I think makes that work. And I think one of the things you said is really worth addressing, which is, yeah, I mean, obviously the reason why you write in Python and not assembly code is that it's much easier, right? And auto rig systems have been very traditionally auto rig systems have been very awkward in terms of sometimes some things become much easier because you're using an auto rig system, and some things become significantly harder. And as a result, and it depends on how your auto rig system is designed, right? Like obviously, like there are real differences between auto rig systems in terms of how easy it is to modify things. And but in my experience, it is very often true, and this is partly why this situation happens, right? Is that very often trying to make ad hoc changes that you need for a particular rig because of some production situation that came up. This happens all the time, and it's just like trying to do it through your auto rig system and your whatever method you have of defining rigs is just like it's just not even on the table, right? It's too difficult. It forces too much structure on you to make it a viable thing for people to do in the heat of production, and that's whereas I sort of look at the way people might do things with control rig, and again, I'm like I don't have much experience with it, so I'm just going off what I understand from looking at it briefly. But it really wouldn't necessarily be like that. I mean, you could get in there, modify essentially the code of the rig without and that's how you actually modify rigs. I mean, essentially, your rig is your code to generate the rig, as it were, and your rig. There's no real division from that from the user's point of view. I mean, there is, of course, in that what's being executed at runtime is not the same thing as your blueprint. It's actually something compiled from your blueprint, right? But you never edit that. All of your tools are available to you. They're as high level as you need them to be, right? And that's
seems
what
like the key is
yeah.
right. The key is something where it really is. This is the only way you interact with the rig,
Right.
and it's convenient to do that, and you want to do that, right? And
Right,
I think if you have that, then I think you're talking about something that's maybe a little bit beyond an auto rigger at that point too, but that certainly has it's sort of an auto rigger. An auto rigger is subsumed into it, is a subset of it.
Sure. I mean that's kind of why I don't really call that auto rigging in the usual sense, right? The whole concept of auto rigging is this is a thing you would normally do by hand, and now it's going to get automated, right? That's where that concept of what does that even mean, auto rigger? And so historically it happened because people were making rigs by hand, and then they and then they were like, well, this is obviously much too slow. Let's write a program that automates this, right? And I think that the division between those things is the source of much trouble. It's the source of much pathology in the technique of rigging. So
anyway,
that was a very, very long rant. I hope that was interesting to people. Because we kind of got a little off track there. But there is one other thing that I will just sort of point out here that I think comes out of this. That's sort of a philosophical idea that I think is like somewhat important. It's that programming concepts. Oh, 1 second. Let's turn off this alarm. Programming concepts are they're very useful to riggers. There's a degree to which, historically speaking, people doing rigging have sort of looked at programming and been like, oh, that's like weird programmer stuff that we don't understand, right? And we're just going to focus on rigging as being sort of this separate thing. And as time has gone on, that's become less true. Like, I think it's a little unusual now to see someone who focuses on rigging who's not doing plenty of scripting too, right? So that was, has changed somewhat. But I think that it is true that there's still this degree to which programming concepts are not well understood in the rigging world. And I'm not even necessarily talking about being very experienced with coding per se, right? I don't necessarily think that all riggers necessarily need to be very experienced programmers in the, colloquial sense of people who use code, who write code. However, I do think that the degree to which the rigging world and the rigging world in general, right, doesn't understand the programming concepts that underlie what they actually do has been really unfortunate and has caused a lot of issues. And so it's worth bringing up the idea that, like, yeah, I mean, we're talking about all this stuff in that rant, right, about like compilers and, programming languages. And, from a certain point of view, you might say like, well, we're getting way off topic here, right? We are really doing something, like nobody cares about this. They're here to talk about rigging. And I just want to sort of note that while, perhaps that is true to some degree, in fact, I became a much better rigger once I understood underlying programming concepts that I had not under like vastly better. And also that while programming concepts can certainly be difficult to understand, I mean that's absolutely true. They're not, in my experience, as scary as I thought they were when I first got into this. Like you remember that, Tagore, like when you first came to Anzavin Studio, and like my knowledge of programming was really extremely limited to the point of like naivete, you know.
Yeah, well, you've steadily gotten better at it over the years, and I'd say especially over the last couple of years, we've worked so closely on,
Yeah,
say, like the ephemeral system and that kind of stuff. I feel like, yeah, it just takes time, like anything else.
yeah, exactly. And so I would say to any people getting into rigging who might be listening to this, right? Like, don't be afraid of programming. Like, it doesn't mean that you have to be a dedicated software developer. I mean, I'm certainly not a dedicated software developer. Tagore is, but it means that understanding these concepts is really, really, really valuable and is going to make you a better rigger and make you understand what's actually happening in your rigs in a way that you might not otherwise. I mean, as an example, I see so many rigs that are overbuilt because people have sort of learned some techniques by rote, and they're like, well, we need these different hierarchies because this is sort of how it's been done. And when you drill down to the conceptual basis of what's actually happening in the rig, like an FK-IK switch or FK-IK blend is maybe a useful example. And we don't have to do much of that here because Contour is just handling all the FK-IK blending in this particular rig, right? But if you are making your own FK-IK blending, there's a degree to which people tend to multiply the number of hierarchies needed for that beyond what's actually necessary. You do need multiple hierarchies for that in a conventional context. But you don't necessarily need as many as you sometimes see people use. And there is a degree to which rigging, and this affects the performance of the rig, it affects like a lot of things. Where you can get to what you're trying to accomplish much more simply by understanding what actually underlies it. And actually, an even better example of that would actually be twist extraction, which again, we don't have to do because Contour just does that for us. But I actually should at some point just show a basic example of rigging up twist extraction because it's a lot simpler than people tend to think it is. And people come up with very, very, and including me in the past, and in fact, there's a funny story about that, as you may remember, Tagore, have come up with very, very complicated ways to do twist extraction, when actually twist extraction turns out to be pretty simple if you understand what's actually happening underneath it. And I know that what I've just described has been super vague. Like, I haven't really been,
Well, are you talking about AMAT, Brad?
Yeah, I am talking about AMAT.
That is a funny story.
It is a funny story.
Sometime maybe we'll talk about that, but probably right now.
Yeah, probably not right now. We need to get back to doing some actual rigging at this point. I see our concurrent viewers have dropped. Perhaps people wanted to see some actual rigging, or maybe they just had other stuff to do. Anyway, yeah. So I was going to talk about PSDs. So actually, let me back up for a second because I don't know who might be viewing this. Maybe some people don't know about PSDs and what they're good for. Pose Space deformers are basically this idea that using the angle of a joint or a variety of other possible inputs, you drive a blend shape or some other, like direct deformation of your vertices such that you can sculpt them into being in specific shapes for specific, the traditional thing would be angles of a joint, although you could potentially drive it with other things. And this is a really valuable thing to be able to do, although it is, I think, something you want to be careful about relying on too heavily. And it's a valuable thing to do on top of Contour. But you have to take some special considerations for doing that. And we actually have a little tool that helps you do that. So if I select his elbow here, and I go over to the Contour menu under Tools, and I create locators to drive a Maya PSD, what that's going to do is to create me two locators on the spline. So this is using not the deform field constraint, but the spline constraint. There are two different types of constraints. And the spline constraint just attaches it directly to the spline. So if I rotate this, as you can see, like it's following the spline. And you may note that these things bow in slightly. And that is because what the bones show you, these straight lines, is not actually what the spline is doing. Because the spline is being modified by the radius of the joint. and creating a little bend inside there, which is why, if I turn on my... Oh, did I just hide that instead of... Yeah, I did. 1 second. What is it? Coat top? Yeah, there it is. Which is why you can control the actual sharpness of your bend by controlling the radius of the joint, right? I can make it sharper or less sharp as needed. And therefore, what's actually happening here... Oh, yes. Let me just ignore that. I should fix that at some point. I know how. I just haven't bothered. What's actually going on here is that the actual spline is giving you a little bend in here, which is why these things are not perfectly aligned with the appearance of the spline from the way the bones draw. And that's perfectly fine. Like, there's no reason why that's necessarily a problem. We can just sort of leave it like that. It's not an issue. But what we can do here is use the rotation of one of these locators. And if we go take a look at what these locators actually look like, they are the forward locator and backward locator. And they both have spline constraints, but one of them is parented to the other, which means that this locator here, its rotation is relative to the one further up the chain. And this is actually really important, because what we want really is to say the rotation of this side of the joint as a delta from the rotation on this side. Because if you had normal joints here, if you just use the rotation of a joint, that's essentially what you're doing. You're saying this joint's rotation in its parent space is what we're going to use to drive our PSD. And if I rotate like this, you're going to get a result that is very similar. Like the orientation of this locator is bending more or less the same amount that this joint is bending relative to the orientation of this locator. The reason why it's important to do things this way is that in the case of contour, that's not your only option, right? You could also do this. You could also just change your spline directly by moving bone CVs around. And if you're moving bone CVs around, then the rotation of your actual joint is no longer valid, right? That is to say, pointing down the x-axis, right, from this joint in this direction, no longer describes this actual bend, because the bone CV and the tangency of the spline at these 2 points is actually what the bend consists of, not the rotation of the joint. Did that make sense? I want to sort of ask that to our viewers, because that was a somewhat high-level description of what's going on here. I'm about to, do it in practice, but I want to make sure that wasn't completely impenetrable. So feel free to break in there if this did not actually make any sense to you. What this means is that I can create a Maya PSD using the forward locator as a driver. So, Maya, your menus, they don't always do what you think they're going to do. All right, there we go. I believe that's in animation editors, pose editor. So Maya had introduced, I think since 2016, it's got its own built-in PSD system, or I should say pose driver system, because PSDs work in a variety of different ways. And the sort of traditional one that comes from a paper that was published in I don't actually remember exactly, sometime in the 2000s, uses a specific type of deformation and drives the vertices directly from it. That's not the way that Maya's system works. Maya's system drives blend shape values based on your pose angles. And so really what this is a radial basis function solver that tries to figure out what values it should put into these blend shapes based on the angle of, in this case, your locators. So I'm going to create a new pose interpolator. Yes, I know. I do indeed want to add neutral poses anyway. There's a bunch of assumptions built into this system that are based on the assumption that you're working with actual Maya joints, which we of course are not, which means we're going to have to just sort of ignore some of that stuff. We definitely want to turn on our advanced options here, because there's a bunch of stuff here we're going to want to mess around with. And so it's created this sort of, here's the default position. So I made sure that this was all in bind pose when I created the pose interpolator so that it would get the correct default pose. I'm now going to go rotate this arm into some position where I think I might want to sculpt it. Like here where it's just starting to interpenetrate, and maybe I want to do some stuff with that. And I'm going to create another pose. I do not want to create a blend shape deformer. I'm going to attach something. I'm going to attach something after the fact. But I am going to create a pose shape. This says swing only, which is, I believe, correct. You can do swing only, swing and twist, or twist only, and that has to do with which axes of the orientation are going to affect your Pose Space Deformer. In our case, because of the fact that Contour handles twist, such that the twist of these two locators, if you imagine I'm twisting this arm over like this, right? The twist of those locators, because they're being pulled off of the Contour spline, are always going to sort of match up at a particular joint. So using twist here is not really a meaningful thing to do in the case of Contour. We might want to make this a very specific angle, actually, so that we can remember it for the future, because their system of going back to particular angles is not going to help us here, because that makes the assumption that you're using conventional joints and you're using conventional joint rotation. So, now let's do an actual blend shape. And we're going to use the shape editor. And here's something that's pretty important to contour deformation. We need to put the blend shape on top. And there's a number of reasons why we want to do that. One of them is performance related. We've sort of talked about that a little bit. Rebinds and contour, well, not actually that slow. And there are scenarios where you can totally use them and it's totally valid. Generally speaking, you want to put your deformation on top. It also is useful in a variety of ways. There's all of this pose extraction stuff or shape extraction stuff that you have to do when you're sculpting a conventional blend shape that goes underneath your deformation. That, there's a variety of tools like shapes that'll do a good job with that. But it will produce a situation in which there's assumptions baked into that, right? Assumptions about the deformation. Because in order to sculpt on top of a mesh and then get a blend shape that can go underneath it, you are creating, you have to sort of unbend the shape. And that creates additional complexity. I much prefer to just put deformation on top, like blend shapes on top of the shape, and then tell them what space they are actually in, which is something that you can do perfectly well. So anyway, I'm going to create a blend shape deformer. I guess I don't really care about calling it anything in particular. I am going to, I should probably name this. Like I said, occasionally you should actually name things. I'm going to call it jacket. Sure. And I'm going to create a target. But the target I'm going to create is not going to be a conventional blend shape target. Instead of automatic, I'm going to use transform space. So here it's maybe worth discussing the difference between transform and tangent space. Maybe I can actually, you know what? Let me do a transform a tangent space blend shape first, so I can show you what the issues are and why I don't want to use it in this scenario. Because I think that is potentially pretty valuable. So here I'm editing a blend shape. This is in tangent space. That means it's on top of the rest of the whole deformation chain here, but it is being used to edit. I can directly sculpt it. It's being made relative to the actual mesh itself. The normals and tangents. Oh, here, let me go change my selection settings. Is my soft select doing volume? Yeah, I want it to do surface so that I can move it around and not cross over. So in order to, I'm about to throw this away, but in order to make it clear, and it can be a little hard to differentiate these things sometimes, I'm going to move some of this stuff in the middle around. And I'm going to turn it off. I have now made myself a, pretty useless, but, it's just there for demonstration purposes blend shape, where I did something where I moved something around on the interior of that bend. I'm then going to bend it out. Did you see that? Boink. Let's take a closer look. Boink. What's going on there? Well, here's what's going on. the actual tangency of the mesh, the normals of the mesh, is flipping, because that's the moment where a bit of the mesh starts to interpenetrate. So if we turn this off, right? So it's not interpenetrating, and suddenly it's interpenetrating a tiny bit. And normally speaking, like, yeah, do you even really notice that? Not really. But it does actually flip the direction of the normals of the polygons right inside that that transition, right where they suddenly go inside out. They cross through each other slightly, and this creates an issue for tangent space sponge shapes. They basically can't handle that, right? Because they are relative to the normals and tangents of the actual surface, meaning that they will tend to, they'll tend to do exactly this thing that you definitely do not want them to do. So this is why we use transform space blend shapes, or why I use transform space blend shapes in a large number of circumstances. Tangent space blend shapes are still kind of useful in some cases, because it is really pretty useful to have something that's entirely relative to the surface deformation itself. It means you don't need to consider what space it's actually happening in. But I do generally use transform space blend shapes for most things. Unfortunately, as we're about to encounter, there is one issue with transform space blend shapes, which is Maya does not have any tools to mirror them, which is very, very frustrating. And we're about to have to deal with that. But let's go make our left side work properly first. So I'm going to get rid of that. I'm going to put this back to like negative 115. I'm going to make an actual blend shape that we actually like. But I am going to say that it is going to be relative now, not to the surface or to, world, which is basically what it would otherwise be. It's going to be relative to this specific transform. So I'm going to say it's going to use this transform. It's going to be in transform space. And that means that anything I do on this blend shape, everywhere that I pull the vertices around, the deltas that I'm making there, the differences, are going to be relative to this space. So as the arm bends, they'll maintain their relationship to this bending arm. I'm trying to think if that's a good way to describe it. I mean, I'm saying some stuff here that's potentially like kind of confusing. Hopefully it will become more clear as I work on it what that actually means. Right, so let me go do a little bit of sculpting here. But a very, like I said, it can actually be kind of painful when you've got stuff like interpenetrating like this to, figure out which vertices you actually have selected. I haven't really found like a particularly nice like way of handling that. It's just, you just gotta like pay attention and try to move the right things around. So let's say we're doing that. Did I undo something here? I am using surface mode. I guess it's like crossing all the way over to the other side. Yeah, that makes sense. Let me make this much smaller. And there's no particular reason we cannot do that in a more extensive pose. I can just pull it up here, because keeping in mind that all we're doing here is creating deltas, differences in the vertices between their default position that they've been put into by contour and where we want them to go. It's perfectly fine to do that in the context of like some pose that's useful for that purpose, right? The bend of this joint is the only thing that's going to matter. Well, not this joint, the locators that surround it is the only thing that's going to matter in terms of driving the PSD. So we can go ahead and do whatever we want in terms of what other controls are doing while we go sculpt this pose. And I'm just going to sort of pull some stuff around. Often this is the kind of thing where it's kind of fiddly and you do some stuff and, you know, decide you don't really like it and then mess around with it some more and, you know, all of that sort of thing that one does when sculpting, despite the fact that this has some of the qualities that wave painting has of being just like, you know, a fiddly thing. It's way easier to do than wave painting in my view because you're just putting things in specific places. And let's say we also want to pull out the elbow a little bit at this point. Let's say we're gonna, I don't know, like he's not really the kind of character who'd have like really notable wrinkles or anything. So I'm not gonna like try to sculpt any of that in. We don't even really have the geometry for it. I'm just gonna sort of play around with this a bit and, you know, try to, you know, make some other minor adjustments. Yeah, I think that'll do. All right. So one thing that you may note about this, leaving on our, here's where the difference between tangent space and transform space probably becomes pretty clear, is that if I rotate this, well, if we do it at this point, we're definitely going to get something weird looking, because this isn't the pose that this was sculpted for. However, note that at no point does it flip out, because it's not based on the mesh, it's based on this transform, the transform along the spline, which is going to behave in a very predictable manner. And that's what you want for whatever drives your PSD. You want predictability. You want something that's not going to flip at some point or in some other fashion, just like, you know, give you an inconsistent result, or perhaps a result without continuity, I think is maybe a good way of putting it. So now we can actually drive this pose, with the our forward locator, you know, pose space thingy that we did here. Let's see. So I'm going to add a connection to the forward locator, and that will allow me to drive some pre-existing blend shape. The reason why I did not make a blend shape automatically when you create a pose, which is an option, I mean, I turned it off. The reason why I didn't do that is because then you don't really get any control over what space that blend shape is in. It just, you know, it just goes and makes what it thinks would be appropriate, which I don't really want. But I do have the ability to just choose a specific blend shape. Although I will say this really should not be called coat top. It should be called like left elbow bend or something. The UI is not smart enough to update itself accordingly. But yeah, here we go. So now we are saying, here's our weight value. And that weight value is going to, and so we're already getting something that kind of sort of works, although we're going to have to fine tune it, right? So we've got this thing, we're like, okay, at this point, if this were, like this is being driven, but if this, so you can't really see it as a slider, but you can see that the value here, the weight value is close to 0, right? At default, it should probably actually be 0. Well, close enough, right? So it is increasing that shape as we go, but we're actually kind of getting something that looks a little weird here. We don't want it to be doing this at this point. And so we can, there's a number of ways of doing this. You can insert more poses. You can also sort of screw around with the fall off. And I think we're going to screw around with some fall off. Let's actually do this as an independent fall off, which is one of our options. And that lets us decide at what angle we start putting that thing in. Yeah, that was too, like, here you can see like it's already interpenetrating and then it shifts to the thing real fast, so obviously that's wrong. Yeah, that seems to work all right. I mean, you could get a better result, right? You know, there's definitely stuff you could do with this that if you wanted to be like really, really careful about it. But I think this is going to work pretty well for our purposes right now. I don't know. I might screw around with it a little more. Maybe it should be a little bit less than that. I mean, like I said, there's a lot of stuff. We could also just insert another pose here. That's also an option. This is also something that tends to be a little fiddly. I am, however, going to say that I think this works reasonably well, right? Because if we think about him sort of in these sorts of poses where he's likely to have his hand there, we can always view, like, what would this be like without our blend shape here? And, like, you know, there's pretty evident interpenetration. We might even decide we only want to apply it part way. because maybe that gives us like a slightly better result. Like we don't really care that there's a little bit of interpenetration. I mean, there's a lot of controls that we could do here. I'm sort of feeling like this is working pretty well, though. If we were to add more poses, I will just note, you might not want to do this with this independent checkbox here, because very frequently when I do PSDs, I will actually use that because I actually only have one pose. And this is like a scenario where I'm like, I wanna sculpt it in its extreme pose, but in other poses, I don't actually care because Contour is already doing something that I think is pretty reasonable, and I don't really feel like I need to art direct that very precisely. If you did need to art direct that very precisely, which, you know, is a pretty normal thing you might need to do, then, you know, you'd probably add more poses, and you probably wouldn't do it as independent so that they blended together more effectively. You probably have to screw around with a whole bunch of like the smoothing values and stuff. But for this purpose, I think this is working okay. Now we're going to encounter an additional issue, which is how do we mirror this? And this is actually going to be quite painful. This is a something that I would love to like develop more tools around, but because we're using Maya's PSD, we actually wrote our own, which is actually still included in Contour Rig Tools under experimental. But when because it required additional development,
I don't recommend using it.
Yeah, you shouldn't use it right now because when Maya released theirs, we were like, well, there's different places we can put our development, right? We can put our development effort into this PSD, but Maya already has one now because, you know, when 2016 came out and they came out with their own PSD system, or we can put it into other places that Maya doesn't, you know, aren't tools that Maya replicates. And someday I would love to go back to that because there are definitely awkward things about the Maya PSD workflow that we could I think do a better job making it simple and effective for users.
Yeah, I think some of our UI around that was actually pretty good.
Oh, yes.
There were some issues, for instance, the stuff you were talking about the tangents flipping,
Yeah.
for instance. We only had tangent space PSDs, and that's something that I think may be solvable, even with the tangent space.
Oh,
But
yeah.
it's you know, it's not something that we did partially right. Maya put out PSDs. We were like, okay, we don't need to continue that down this road. I think we did feel like Contour works really well with PSDs, and it was really important that there be something.
That be an option. Yeah, it was super important.
Right.
But it was not important. Like basically we figured. Whoops, let me switch this to FK. Sorry. It was not important for us to sort of make it our own PSD that was compatible with Contour. Although again, I kind of do want to go back to that someday because I do really think that there are ways that we could make this significantly easier to do. As you can probably see, you know, I'm having to do a bunch of work, like screwing around with different values and, you know, understanding some of the ways that this deformation is going to layer together. That is, you know, a lot of that could probably be automated and made a little clearer and more accessible to the user than I think it is right now. That's not to say that this is a bad system. You can use it perfectly, pretty effectively, and I do a lot. Although it is worth noting, and you will notice this when you, if you download Contour Man, and you're using any version of Maya other than I think 2022 with what do they call it again? Right, it's GPU override. I'm sorry, my brain blanked on that for a second. If you're using GPU override and you're using transform space blend shapes, you will get incredibly bizarre results and also probably crash Maya. And that's a bug that they fixed, but it is still, you know, it's still something you've got to deal with unless you're using Maya 2022. The only real way to deal with it is turn off GPU override. But the problem we're dealing with right now is that there are no mirroring tools. So if you're doing tangent space blend shapes, or if you're doing conventional blend shapes that are just object space that go underneath your deformation, then it is perfectly, I mean, there are existing mirroring tools and they work fine. Maya neglected to do any transform space blend shape mirror tools. And it's possible to sort of see why they neglected to do that, because it does require a little bit more thought. It's pretty, so in the case of object space blend shapes, it's pretty straightforward what you should do mirroring them, right? You know, where you have vertice positions on one side, and then you should put them over on the other side, and you match up the vertices probably by space, right? In many ways, it's pretty straightforward to think about how you would do that. And in the case of tangent space blend shapes, it's basically the same thing, only you start out with the world space position of the vertex, flip it over to the other side, and then figure out what that is in tangent space, and that's your answer, right? In the case of transform space blend shapes, though, one of the things that's really clear about this, and actually let me make this really clear, actually, because if I go over here and I start activating the blend shape, and I move my forward locator around, it's not going to let me do that, right? For the moment, I'm gonna break these connections, and I move the forward locator around. Note that the deltas of these vertices, the way that they're being pushed around by the blend shape, because it's relative to this locator's transform, rotating the locator will change what the angles are. And this is actually good. I mean, this is exactly why tangent space blend shapes are great, because as long as that locator is locked to the orientation you actually want it to have, which is being, controlled by the spline, then even if I rotate this down here, like, I'm getting the right result, because it's relative to this locator, which is also following along. So it's a way of getting around all of the issues that putting blend shapes underneath your deformation would normally have gotten rid of back in the past. I mean, one of the first things that almost anyone who's just setting out to do rigging in Maya does, and, like, including me, like, this is what I did in, like, 1999, maybe? 2000? Probably the first time I ever used Maya, maybe? I'm not really sure. A long time ago? Damn, that's a long time ago. The very first thing I did, because this is what everyone does, is they put some bones in something, they paint some weights, and they put a blend shape on top, and they push something around, and then they animate the character in some way, and of course all of the blend shape values are wrong, right? They are pushing the vertices in the wrong direction. And the answer, as everyone finds out immediately, is stick your blend shape underneath the deformation. And because we don't want to do that for a wide variety of reasons, right? We need some space that's the correct space for that blend shape to be pushing points around it. And that's what you get from using these transform space blend shapes. I know I've explained this like 3 times. I'm just trying to, like, make sure I don't say something where it's really impenetrable to people who are impenetrable. Apparently I can't talk right now. That it's really impenetrable to people who are not necessarily, like, already familiar with some of these rigging concepts. Like, I'm trying to make it a little more approachable, and so I keep trying to explain it different ways. Possibly I'm just wasting time and saying the same thing 3 times. I don't know. But in any case, the reason why Maya's always had such a difficult time with that, or at least I suspect the reason why they never went and made a point of developing that tool, is because you also need an equivalent transform on the other side. Essentially, it's the same problem as using transform space blend shapes and mirroring them, right? You find out what position you need your vertex to be on the other side of the mesh, right? You find out what position your vertex is relative to tangents on this side. You figure out what it needs to be on the other side, and you look at what that needs to be relative to the tangents of your mesh, presumably, right? I mean, I'm assuming that's how it works. To do the same thing for transforms, you need the transforms to have a canonical position. Like, the mesh kind of already does. Like, its bind pose is its canonical, state. Some random transform doesn't have a canonical state. You would need to supply it. And I think they kind of looked at that problem and the fact that you needed those things to line up really well and be properly set up, and said, this is too much for us to convey to our users and like actually get it working properly and deal with all of the possible cases of people doing it wrong. Therefore, we're going to throw up our hands and say, oh, you just can't mirror transform space blend shapes. This is, to me, very frustrating because transform space blend shapes perform better than pretty much any other method of doing blend shapes. They're really, really nice. And it would be really nice if there were decent mirroring tools for them, and there aren't. What you could do is kind of a hack. And there's a variety of ways of doing this kind of a hack. And I'm actually thinking about which one I'm going to use on this stream. I actually have a little tool that I wrote for myself that does this. However, the tool is really, really ugly. And I don't really want to expose it to other people. because I'm like it would need so much work to be something that I wanted to like give. Like, I'd be happy to give it away open source or something. It's not like a important tool that I spent lots of time developing. But I also am. I think it would be really difficult for people to use. It has a whole bunch of really messed up assumptions. And so I am inclined to say that I want to do this for you by hand. And the question is, what's going to be the least labor-intensive way of doing that? Because the normal way of doing it is super ugly. Yeah, here's what I'm going to do, actually. I think this will work. Yeah, it's going to involve a little bit of ad hoc Python. But it should get us a mirrored transform space blend shape reasonably enough in a way that hopefully other people can follow along with. There's also, and maybe I should actually do this, because it would be accessible to more people probably. There's also a really dumb way to do it, which is to actually do it manually. Which is to say, just like actually mirror your mesh over and then just look at it and snap the points to where they're supposed to be. And that, of course, is like the worst possible thing to do. Right? It's like super labor intensive for like, it's super labor intensive. It just it's like you want to make a change, now you've got to do it again, right? It's not a great solution. However, it is a solution that anyone can follow along with, even if they're not particularly familiar with Python. So I am going to, I was going to throw it out to the group, but I'm actually thinking that in this case, because we don't have a whole lot of viewers right this second, that probably what makes the most sense, because this is mostly going to be useful to people watching it after the fact. So I'm just going to make a decision to do this the hard way, because I have definitely gotten some comments from people saying this is great, but like we can't necessarily follow along with some of this stuff because you're doing so much ad hoc coding. So I'm going to do this. I'm going to do this the dumb way, and it's going to be kind of ugly, and it's going to be a little time consuming because the mesh is not super dense. It will function, right? It'll work. And it'll be something that we can do successfully. So yeah, I think I'm going to do that. All right. So here's what I'm going to do this. First of all, I'm going to turn off the blend shapes. Oh wait, no, actually, I need to turn them on. Quite the opposite. I'm going to make sure that everything else in the rig is zeroed out. Like everything except the bend of these two arms. Let's just make sure that that's actually true. Yep, everything else has is in its default pose. I'm going to make sure that both of these are bent at the same angle, specifically the same one I did this pose at. So now we've got two different versions, and it's essentially the difference between, I mean, you can see the difference here, right? Here we've done something to deal with the interpenetration, and then on the other side, we have not, and it interpenetrates, right? So I'm going to duplicate this mesh. You're going to see what this is, and you're going to be like, what in the world is he thinking? Like I said, I don't normally do it this way, but I want to make sure this is something to follow along with. Note that here, we can very clearly see what the difference is, right? It's this versus, well, it's hard to select, but you get my meaning. I'm going to turn off my flipped coat top. I just, to be clear, I just scaled that -1 on X in scale in order to make the two things match up. In order to get a flipped version of it, basically. I am going to create a right elbow blend, just the same way I did for the left. Oh, right. Yeah, good point. I actually have to not quite done all the things I need to do. I also need to actually add my, actually, come to think of it, I changed this radius to be 2.6 over here, and I didn't over here, and I'm going to make sure that I do that, because otherwise these things are not going to match up as well as I would have liked. You really do want it to be the same on both sides. I'm going to create my PSD locators. I'm going to create a new pose interpolator using that one. Yes, go ahead and add neutral poses anyway. Oh, did I click no or something? Because I don't see any neutral poses there. Let me try that again. Yes, please do delete it. Create pose interpolator. Ah, yes, I did press no, even though I had no intention of pressing no. There we go. And now I've got something I can actually use here. Got to make sure the angles are the same. Oh, and one thing I should perhaps note, because I hadn't really mentioned that before when we were testing this out. The whole reason, and I sort of mentioned this, but I talked about it entirely verbally. We've got these two locators, and the fact that because they describe the tangency of the spline at these particular points, they're better than using the rotation of the joint. Because what I've done here so far is just rotate the joint, and in that case you could say, oh, well, you could just use joint rotation. But here's why you can't. Like, look at that. Like, you can see the thing coming in as I change the spline, even though I haven't rotated anything. And that's what you need. Actually, I'm really thinking I might adjust the. It's still too abrupt. So I might play around with that. I'm going to come back to that in a second. But that's the thing that using these locators really gets you. It's the fact that, in a sense, the contour spline itself is what's controlling the PSD, not the rotation of any given joint. And that's a really important concept. And it was something, for instance, when we wrote our own version, our sort of, experimental, don't actually use it in production version, we were able to use that data much more directly, which is one of the reasons why it would be really nice to get back to that at some point, because all of this stuff where I've talked about having like the right primitives and the right the right structures in your rig that sort of do the right things without having to manually insert a bunch of stuff. This kind of breaks away from that a little bit. This is a little bit of a sort of a concession to working within Maya as it currently exists. In an ideal world, you wouldn't have like actual locators here, but in the world in which we want users to be able to use the Maya PSD system as it currently exists in a way that they might already be familiar with, using transforms as inputs, this is kind of what we have to do. And so in the long run, I really would love it if like more and more stuff of that nature can be sort of removed from the Maya node graph and placed into something sort of internal to Contour. But obviously, like we are bound by what's reasonable and possible to do, right? We did a lot of stuff for Contour to automate an enormous amount of stuff, and some things are not quite as automated as one might theoretically like. It's still going to save you a truly enormous amount of time. Anyway, after that rant, let me do this truly horrific thing I'm about to do. Right, so I'm going to add... I'm going to grab my forward locator here. No, that's not what I was trying to select. Thank you. I'm going to grab my forward locator. I'm going to create a new blend shape deformer. No, I'm not going to... Sorry, I'm adding a target. I'm going to add a target with this selected locator as its transform space. So now I have essentially equivalently on the other side what I previously had on this side. Oh, and I'm actually momentarily going to break the connection here. One of the things about RBF is that, solvers, is that you do sometimes get this thing, especially if you're smoothing it out, where depending on the angle of the joint, even at that angle, you may not get something that's exactly one. And here, for purposes of having the same exact thing on both sides, we need to make sure that it is. So I just broke the connection to the pose editor so that I could make both of these values one. I'll recreate it afterwards. So, time to do something evil. I'm remirroring it because of the fact that there was not previously a that was not previously at full. That pose, the left elbow bend pose, was not previously at full when I mirrored it previously. And since we want the exact same thing at the other side, I wanted to make sure that it was. Yeah, so I am going to turn both of these to unsmoothed. I'm going to throw this one in a layer. I'll turn that layer to, you maybe see where this is going. Let's see if it actually lets me snap. It's been a while since I did this because of the fact that I have a tool for it. And so, does it actually respect snap to points? No, it doesn't. I wonder if it does if it's a reference. Yeah, it does. Okay. So, can you see where this is going? Because it's not going anywhere good. It's going somewhere very, very dumb. Yeah. Essentially, the script that I wrote does something very much akin to this, just automatically. But I really did want to make it something where what was actually happening was more apparent than I load up some script I wrote a long time ago and run the script and then it magically happens, right? That doesn't really teach anyone anything. I really would like someday to like clean that script up, give it a UI, and like put it out, open source or something. Because this is a tool that Maya really, really needs. I'm just really reluctant to put something out that I don't think people are really going to be able to use because it's too specific and its assumptions are too specific. If that makes sense. And this is, of course, the sort of thing that can be extremely confusing. Kind of not what you want to be doing, in theory, but we're doing it anyway, because that's what we've been forced to do here. This is how dumb we're being now. I didn't realize how many vertices I actually ended up moving around. So, yeah, this is going to be painful. Sorry. Maybe I should have used the script after all. I'm already doing it, so I'm going to keep doing it. I'm just looking at like the connectivity of the edges and like trying so I can see what vertex goes where. Like I said, I don't really recommend doing this. Like I'm kind of surprised that I actually ended up talking myself into doing this. I haven't done this in a long time. All right, what's going on? Where's this one coming from? I think it's here. No, it's clearly not. I think this one goes down here, maybe. Yeah, I think it does. That looks about right. How about this? Is that actually this one? Yeah, it is. Nope. There we go. This is starting to match up. And we will know when we're done when there's no more of these black lines. Yeah, I think we actually got it now. That hurt me. That hurt my soul. I'm never doing that again. It's been a long time.
Yeah. Well, maybe we should clean that script of yours up and make.
We really should. I would love to. It's like right now. It's just very, very like. There's so many ways it can break. It was something I just wrote in a fit of pique where I was like, well, I'm obviously not doing this anymore. I'll write myself a script. But it's like it's really not something I could just hand off to somebody else. But we really should. Yeah.
We actually got a comment on the last stream, which I was going to mention to you because I thought maybe you would want to respond to it. But about this, basically, about I do not have it open right now. But basically, from someone saying, well, who had seen the ad hoc Python stuff you're doing, for somebody who doesn't do ad hoc scripting and isn't very comfortable with it, would we want to, make some of these tools available in some fashion? Um, and I don't know. That's a little bit of a tricky question to answer. I don't want to drag things really off course. I
Sure.
think that some stuff, though, it would be good to, some of the stuff you have. It might be a good idea to make some of it available in some fashion. We should maybe talk about that at some
Oh,
point.
absolutely. I mean, the main thing with making ad hoc Python stuff available, I feel, is that when I'm writing ad hoc Python stuff, like all the work that goes into development, like there's no error checking, there's no
Right.
UI, there's no
Exactly.
like I'm just writing some stuff and I'm just about to throw it away so it can just be whatever. And I think that it would be a lot of work probably to
Right.
make that stuff sort of available as some sort of actual toolkit. That
The
said,
other Well, right. The other thing about it, though, is that the ad hoc stuff has a kind of power in being ad hoc, in that you can just sort of do exactly what you need for your current
that's right.
situation,
That's
right?
right.
So if you make something fixed ahead of time, it may not fix that situation. I do think it might be reasonable for us at some point, though, to sit down on the stream, to have a stream, or to a recurring thing with the stream, to take a look at what kinds of ad hoc Python are useful, because honestly, you can get a lot done with a very small amount of Python,
You
right?
really can, actually. I think that's actually a really good idea. I mean,
And I think it really is worthwhile for people who are rigging to become at least a little bit comfortable with Python. It's not about like you have to learn a great deal about programming, but if you can do a few things, I mean, I know you love your list comprehensions a great deal.
yes, I
So,
do.
but I mean, like this is a couple of like little PyML things you can call, and this is how you do a list comprehension. And I mean, you can do a lot with a very small number of tools there.
It's actually really true, and it goes back to what we were talking about too, about how like it's really valuable for people doing rigging to understand some programming concepts, not necessarily to be like really really experienced developers, but just kind of understand the concepts involved. And the way you start doing that, certainly the way I started doing that was, I mean, you remember this, Tagore, just learning enough Python to like code myself little things when I really, really needed to, so I could stop bugging you and Brian about it, right? Or Morgan or whoever was on hand, right?
Yeah.
And then from there, I started to learn actual programming,
Right.
right?
I mean, and you had the advantage of having. I mean, this of course was back when we all worked in the same office,
Right, in a
and
physical office,
I
right?
was in a physical office, and so I was about, I mean, I was about 6 feet away from RAF 40 hours a week, so that's helpful, right? I mean, you had a number of, between me, Brian, and Morgan, and then some other people at various times. You had a
Right.
lot of people around who were able to help with that. But I do think we could do something like that on the stream and talk about that, because I think it's really useful stuff to be able to. I mean, there's a lot of aspects of Maya. I mean, I don't rig anyway, but there's a lot of like tooling in Maya that I don't even know how to use the tooling, because it would never occur to me to not just do it in Python.
Right, exactly. And there's a lot of stuff that I do in Maya, and we've sort of discussed this a little bit before when I was doing some what they sometimes call noodling, right? Where I was like, just kind of like hooking some nodes up, and I was mentioning that, like, yeah, a lot of the time I just do that by command line because the node editor can be really awkward, right? And it is really helpful to be able to just like ad hoc script some stuff. And I mean, I've been trying to sort of show that on the stream too. Like a lot of the stuff that I was doing with ad hoc scripting, you could do it by hand, sure. It would be a huge pain though. Like it would take like 10 times longer. Except, I mean, of
Sure,
course,
we go over a little bit of the anatomy of some of it.
right, exactly. The thing that I think is probably true of this mirroring situation though is it really might be worth us taking a look at that tool and seeing if we can turn it to something we can put up, because it's such an important thing, right? Being able to mirror transform safe blend shapes, and the fact that Maya just utterly lacks tools to do that, it's just missing, is like, it's the sort of thing where, and this again goes back to that question of riggers knowing some programming, because like part of the reason, there's a lot of reasons why you should, but one of the reasons is you are unquestionably going to run headfirst, almost certainly, into something in Maya that you basically can't viably do. Like that whole thing that I just did. Like, yeah, it's fine to do that for this one character, for this particular elbow on a stream, like where the mesh isn't that dense, right? Like whatever. It didn't really take that long. It took like 5-10 minutes, right? Not the end of the
Right.
world. But if you were making lots of characters in a production pipeline, doing that would be insane.
Right. Yeah. If you're doing that for 100 characters, and also if they're
And also they're much denser,
than that,
right? Like this is obviously the worst. I mean, it's a terrible
then
idea, right?
right. Like, I mean, you're actually talking potentially about hundreds of hours.
Right.
You know?
Right, like
Which,
it's absurd,
yeah,
right? And so
it
you,
is
you
absurd.
you absolutely, and of course, what people have often done if they encounter problems like this, what do? Why, they script themselves a solution, just like I did.
Sure. I mean, I think if you're in a case where you're doing 100 characters and they're very dense and it's going to take you 100 hours, it's almost for sure that you're going to script it and you're going to have the resources to do it. Either you'll know how to do it or you'll have somebody
on hand who does know how to do it. Yeah, that's absolutely true. And so, but I do think that this is something where it's like, the uses of transform blend shapes are not well understood among riggers in general, in my experience. And number two, the fact that they're the rigging tools, like the use of these, frankly, very, very useful tool is seriously impacted by the lack of mirroring tools. And so for this, I'm like, yeah, maybe I don't know exactly when we'd have time to do that. We have a lot of stuff going on. But I would really like to sit down and maybe take that tool and make it something that we could just put on GitHub or something. Because it's something that is desperately
Or, the other thing is we could both put it on GitHub. But, there's nothing keeping us. The thing about it is that I want to enforce a certain level of code quality for stuff that actually ships with rig tools. Right?
Absolutely, right.
But, rig tools doesn't have to be entirely about the rig tools deformer. It's called rig tools, right?
That's true.
And that's a tool for rigging. And the thing is, I don't want to make it too big either, though. I don't like software that starts to look like an airplane cockpit, right? It's, it's like this does everything but the kitchen sink. I like things that have a certain cohesiveness to them and a certain focus. But this is probably useful enough that there might be like a utility menu in there somewhere waiting to be born, and we could throw some.
Yeah, I could really see that. So, I am starting to think that might not be the worst idea. I mean, the nice thing about making it just a script is just that it's like, well, we don't have to version it along with rig tools. We can be a little bit more loose about it, like you're saying. Like we're shipping something with rig tools, a product that we charge people for. Like it's got to be bulletproof, right? You make a script, you can sort of be like, well, this is probably pretty useful. But we don't necessarily have to be quite as rigorous about it, right?
Exactly.
But on the other hand, this is really a pretty critical thing, and it really would be extremely helpful. I don't know. This is definitely something to think about. I will say that. But anyway, we now have like an actual thing here we can use. Let me just hook this back up because it's almost 5:30, so we're almost done with this particular stream. But let me hook this back up to the Pose editor. Here's the thing that I think is also really worth noting, and a lot of this is because, of course, we spent an enormous amount of this stream with me just ranting about like auto rigging and other subjects, and like that's a big part of the reason why we didn't like actually accomplish all that much rigging this stream. But the other reason why we did not accomplish all that much rigging stream is that we exited, in a sense, the world of Contour, right? Obviously, Contour is what's ultimately driving these locators that are driving the Pose editor. But one of the things that's been like really, really, really important that we've spent a lot of time like trying to ensure with Contour is that things were just, they kind of work the way you'd expect, and it's not hard to like make them behave appropriately. And we have now exited the world of Contour. We're now in the world of sort of like more conventional Maya rigging, so that we're putting on top of Contour. And I think it's really, this is like a point that's worth noting, like in terms of like the orientation of where your work goes, like where your effort goes. That we've now immediately hit a situation where look how much longer it took us to get like these PSDs working and doing the right thing, that it took us to get the initial Contour. Like that first stream, we did like the whole spine, and we did all of the like, the constrained up controls and stuff, and like we got an enormous like that's an enormous amount of like rigging done actually from scratch.
And you actually were also, I mean, you were ranting a little bit.
I was ranting then too, right? And now we've exited that world into like the Maya rigging world, and look how freaking slow everything is.
Yeah, well, and not using that script for that as well.
Well, yeah, of course that also had a big effect, but when you really get down to it, that was only about 10 minutes.
Sure.
Of course, I was explaining a lot of stuff too, so like, it's hard to say. Yeah. But I do think that this is really notable. Like, this is really an example of just how complicated rigging tools are, and how much of a problem this is. And I think this is, and now I'm getting back into a rant, but I think it's an important thing to sort of touch on. Like, it's not just that the tools are complicated, because ultimately all rigging has an element of complicatedness to it, right? Like you do have to think about some complicated, even if you're just using pure Contour, there are certain things you need to think about, like double transformation, right? That can be hard for people to get their heads around. But, although, of course, if you're actually using pure Contour, you actually don't have to think about that. I'm thinking about, like, the stuff I was doing with the layer deformation. But, a lot of scenarios you do have to think about stuff like that. It's that rigging is complicated, not just conceptually, but also in terms of the friction of using the tools. You're never going to get, I mean, this goes back to a lot of the things we've talked about with animation too. Like, you're never going to remove the truly inherent complexity of creating a good animated performance. That's not going to happen. There's always inherent complexity to that. And there's always inherent complexity to creating the deformation of a character rig. But in addition to that inherent complexity, we also have an enormous amount of friction in terms of how the tools are built and how they work that goes on top of that.
Well, there's a term, incidental complexity.
Yeah.
Right.
And like, we've kind of, the moment we left the world of like the stuff that we designed Contour, working directly with Contour, we immediately ran into a situation where the workflow is time consuming, right? The workflow is awkward. You have to understand a whole bunch of stuff that is important to understand, but you have to, let's see if I can think of a good way of describing this. It's not just that you have to understand a complicated subject or something that's hard to get your head around. It's that you have to understand how to express that subject in a way that's somewhat oblique. Like, if you think about how you'd probably want something like PSDs to work in a theoretical system in which they were meant to be very easy to manipulate, I don't think that it would work quite this way. There's a lot of considerations here in terms of what do the locators do, what are they relative to, what rotation angles are actually going into this, and what do they mean. That while you may have to understand, there's just a lot of steps involved in expressing what you're trying to do through this UI, through the relationships between different entities in this rig, that become time-consuming to manage, and that it's easy to make mistakes about, right? Like, one of the things that's maybe not clear here, because I've done this particular thing like about 1 million times, right, is that the first time I did any of this stuff, I just broke everything like 10 different ways, right? And everything about conventional rigging is super brittle. And if I want to sort of leave something, for at the end of this stream, maybe it's sort of like, Contour doesn't remove all of that brittleness from rigging, like, across the board. Like, we're immediately encountering some here, right? But what we're trying to do is to pull rigging away from this context of being just, like, really brittle and really, like, full of friction, and try to make something where you can express your ideas in a much more direct fashion. And hopefully that's something that sort of makes sense and is, a meaningful idea, It's a hard thing to do. That's why it's taken us so long to even get this far.
Yeah, well, that and other reasons.
That and like
a variety of
right. There's a variety. Yeah, absolutely. There's a variety of reasons why it's been like this. But anyway.
But that said, I guess this is probably a reasonably good place to break off.
Yep. I just want to hook these things back up so we can just see them working, and then I think we're going to break off. All right, I gotta go add a pose. Do not create a pose shape. This pose, because it's posed already in an appropriate position, should be correct. I'm going to add right elbow bend. I'm gonna just set, let me just turn that off in case I had the edit thing checked, which meant that I could have accidentally pulled on something and edited that pose by accident, and I didn't really want to do that. Let me just get the same values. So this one is independent rotation fall off 33. Give it the same thing. Whether those are really the right values or not, like, I don't know. Like, we could say that we should play around with it more, and certainly more work could be done to refine that, but for now I'm just gonna keep it that way. And now we've got both sides doing what they're supposed to do. And this is going to keep working, even if instead of rotating joints, we are using bone CVs. Although I noted that I didn't actually add any to this one. Let me just do that real quick. Now, not that you can really tell, but like from that position. But let's say I bent this. Here we're getting the thing. I'll use the bone CV to move away from it. Well, again, This arm is so thick that you kind of can't entirely tell, but you kind of can a little bit. Like it's happening regardless of what changes the angle here at the joint, whether it's the CV, whether it's rotation. That's how I should have described it before. I should have used the word angle. I'm a little concerned that my description of what was happening there was like kind of impenetrable to people. This stuff could be hard to talk about. But yeah, now we've got like the right kind of shape for the arm, even at fairly acute angles. And really, like conceptually, you know, as opposed to like the actual amount of stuff that we had to do here, it didn't actually take that much to make that work.
Right. And there's kind of a point here about it, which is that, you know, Contour does make pretty nice shapes out of the box, but it doesn't, there's limits to what it can do.
Sure.
But the thing is that correcting them with blend shapes is vastly easier. Like starting from a good base, you know, I mean, and that's one of the reasons we were talking earlier about how we did at one point write our own PSD before
Maya
real one got included with Maya, is that we understood that this was a really important thing, that Contour works very, very well with Pose Space Deformers, with corrective blend shapes. And it makes using them a lot easier. You know, instead of using them to get something that's just sort of decent and having to layer a lot of them, you start from the place that's decent.
That's right.
You know,
and that's
get exactly what you want.
And that's really important because PSDs become extremely difficult to manage if you've got a lot of them. Especially because if you've like, because you'll see rigs where people do this, where they've got like, oh, I'm rotating the shoulder and I have like 12 PSDs or something. I got 12 shapes that it's going to take in different conditions. And the thing that you get out of that is that unless you're very, very careful to make everything in those shapes and the way that they move with each other congruent, or you generate them through, you know, like sim or something. I mean, there's a variety of ways that you could do it in a sort of automated way. Unless you're doing that, you're almost guaranteed to get weird flickering and stuff, you know, verts like popping all over the place because you're transitioning really quickly. If you've got a lot of them, you're transitioning between them really quickly. Here we've got one, and like we transition to it in like a certain area of the rotation, and otherwise everything's kind of just normal. If you do it quickly with a lot of them, then keeping that manageable just becomes an incredibly difficult challenge. And PSDs are great, but I really do feel like people overuse them or use them in ways that aren't advantageous. You really want to just use it in the most important art direction cases where you're like, I need to be really exact about what this elbow looks like or the shoulder or whatever in this particular way. And like, it's important to me to like be able to like very clearly art direct this particular thing. Like they're great for that. They're amazing for that. But you really, really, really have trouble when you're trying to use them to fix issues instead of to introduce sort of art directable shapes. Like you run into real issues. And this gets you around a lot of that. You have a stable basis and you just use them exactly where you need them. Anyway, now I think it's time for us to get off.
Now, probably time to get off. All right, well, thank you very much.
Thank you for everybody who has watched our stream. Like and subscribe. I'm obligated to say that, I think, like contractually, right? That's how it works. But you definitely should like and subscribe. And also point anyone who you think would care about this stuff over to our stream, because ranty though this stream was, hopefully those rants were sometimes helpful to people, I hope, right? You know, so maybe some people would like to actually see me rant. And number two, there's a lot of like stuff here that's potentially pretty valuable to people. Absolutely, like every stream we have, you know, goes up to YouTube immediately afterwards. That's just how YouTube does things. They're all accessible. Like, you know, feel free to like point anyone you want to.
And you can fast forward through the rants.
And you can fast forward through anything that you don't want to hear, which is actually, I think, a really important feature. I also started actually doing some clips. And also to respond to Radane Ali, I think just said, just arrived. Please, sir, bring back TSM3. We need your magic. Thank you. We're not going to bring back TSM3, and there's a lot of reasons for that, and one of them is, as you know, if you go back and watch the earlier part of the stream, you will discover that I have a giant rant about how evil auto rigging is, actually, and how that's not how we want to be doing things in the future. It is
a funny thing, though. We have talked about putting about putting something auto rig like into
Yes.
Contour. We've talked about it. I don't know that we have concrete plans.
Right, and I think that would be in many ways less destructive than conventional auto rigging because
Mhm.
there'd be less of it. If you see what I mean, right?
Right.
Like it wouldn't be so bad to have. You would think about it as like, oh, instead of here's an auto rig system and we're generating all of our rigging through it. Here's just a tool you can use to like throw some stuff onto an arm and it works pretty well. Like that's a different case, I think. Right? Having some just like basic tools to generate some stuff for you, but there's no expectation that you're generating your entire rig through this. That would actually still be, that's I think a much better case for me. Nevertheless, and also to respond, so here's his second comment. I understand, but we as animator are clueless. That is actually a big problem in terms of how do animators deal with rigging actually. And it's a problem that I don't know quite how to solve because I don't think that auto rigging in the conventional sense is the right solution, but you're absolutely right that some solution ought to exist. Because of the fact that, yes, it is absolutely true that animators should be able to make some rigs without having to understand rigging. And part of the problem that we have here is that there's been a conflation of what I think of really as being two different roles in rigging. There's the programming side of rigging, which fundamentally is like, if you are constructing a control rig and deciding how it works, you are doing programming, right? And it's not reasonable to expect animators to understand that. Animators don't, I mean, some animators are programmers, right? That does happen occasionally, I am. But like, it's not normal, and it's not something that you should have to expect. And when you're asking animators to construct their own control rigs, you're essentially asking them to be programmers, and that's not reasonable. But then there's the other part of rigging, which is I place joints in a character, and I decide on deformation. And that's not programming. That is something that there ought to be good tools that let an animator just do that using rig behavior defined by someone who is a programmer. And that's really quite difficult to arrange for in Maya.
It is. It's a hard problem. I mean, Contour is an attempt to make a step toward that. And I think it's pretty successful at making a step toward that. But it doesn't completely solve the problem, as we see here today. I mean, you're having to step into Maya quite a lot.
That's right. And one of the things that I maybe should have done, actually, is I should have maybe rigged the entire character before doing any PSDs or stuff layered on top. Because it's not actually that out of the question for an animator to rig up something from scratch with Contour if they're not doing some stuff like this. Maybe I should have done this in a different order. Because it would be nice to basically show someone, look, starting from scratch, here's how you can kind of get a rig, and it's actually not that unreasonable to do.
Well, I think it might be reasonable at some point. I mean, I think we should.
Yeah. We should keep going with what we're doing.
Keep going with what we're doing, but it might be reasonable to have a stream where, number one, we keep the ranting to a minimum, and number two, grab a simple character and just basically speed rig it with Contour, because it is possible to make a pretty capable rig pretty quickly with it.
It absolutely is.
Right? It would be good to demonstrate that.
But
it doesn't solve all of the problems of rigging, right? It's not a full solution to the problem. So, but it is hard to make that happen in Maya.
It is. Now, I do feel like if you look at the direction control rig is going in Unreal, you can see the direction, right, that could go, right? You can sort of see the idea of like, look, here's a bunch of essentially rigging functions, which could potentially be things as large as here's an arm, right? That you can sort of hook up in a reasonable fashion. Where, again, like I don't want to talk too much about control rig because it's not something I have a lot of experience with. But that methodology, that sort of concept, would, I think, allow far more easily than you can in Maya for people to be able to kind of make some rigs by placing some joints and then attaching behavior to them that doesn't instantiate itself in the scene in quite the same way that it does in Maya, which is one of the reasons why it's so painful to figure out what workflows like that ought to be for Maya. I mean, auto rigging is an attempt to do that, but auto rigging has all these issues, right? So yeah, I mean, there's just you're absolutely right that there's a gap here, right? And filling that gap is difficult. And I don't think that, for me, I don't feel like part of the reason why we're not making TSMs anymore, there's a variety of reasons for that. One is it's owned by Ansmith Studio, and Ansmith Studio is now defunct. But, and like what we're doing with Notional Pipe is sort of a different thing. Right. But we other... Do not,
yeah, we don't own the IP to TSM.
Right. The other thing about it, though, is just that I find TSM now very unsatisfactory. right? Like, I don't feel like it's a good solution to that problem. Certainly, you can argue that any solution is better than none, and I really understand that. Like, I do kind of feel people's pain about like, but what are you gonna do, right? It's a whole thing. But
Well, I mean, I do think that we were discussing this earlier, for
yeah,
instance, just in the case of the mirroring, which is that this is something that it probably would be reasonable to add to rig tools. And we have a lot on our plate right now with the ephemeral system. We're working and other things. We're working on a variety of fronts at the moment. But I do think that it would make sense to continue to add functionality to Contour that brings it closer to that, that can that can bridge that gap a little bit more. I mean, you can get a pretty reasonable rig out of Contour in a lot of cases just by placing bones. But there is still that gap in that it's really not a full solution. There's a lot of stuff that you still do need to do using the Maya nodes, but we could start pushing out the boundaries of that. And I
right.
think that that's something that, is reasonable to do. We have to see how successful Contour is going to be in the long run before I think we invest a huge amount of development effort into that. And we have to get the ephemeral system out too.
That's right. I mean, essentially, what it comes down to is we have a lot of stuff to do. Plus, like all of the other work that we do, right? It's like there's a lot going on. So that's really the primary reason why we're not addressing that right away. It is something I really want to address, though. Like, I do really feel like there's something really critically missing in the whole world of rigging, and hopefully, and Contour is a part of fixing that, but it's not the entire thing. So yeah, I mean, that's absolutely a concern, and we're going to keep thinking about that problem and trying to come up with better solutions for it, basically.
Yeah. Anyway,
Now I really have to get going.
We should get going. But for everybody who's watching and for everybody
absolutely.
who came by earlier, thank you very much for coming by.
And Radane, I thank you very much for bringing that up, because it's a really important point, actually. And
yeah,
I would love people to just
need to apologize.
Yeah, exactly. There's absolutely no need to apologize. No, not at all. Like the Contour does 10,000 things that TSM doesn't do, right? Like it's vastly superior to anything that TSM is capable of as a rig. That said, there's absolutely, like, bringing up this question of, like, how do animators approach this? Like, this is a really important question. So you should not apologize in any way whatsoever. Like, I am very happy to have your feedback.
Yeah, and I think it's something we can talk a little bit more
Yeah.
about in future streams, about it, because it is an interesting, it's an interesting and difficult question.
Yeah, it is. It's a hard problem.
Yep.
And Maya makes it more difficult, frankly, than it would otherwise be in many ways. But anyway,
Okay.
I
Yeah,
gotta
thank
sign
you all.
off.
Thank you all very
Yeah,
much.
thank you all very
coming
much.
by, and like and subscribe.
Yeah, exactly.
We'll see you next time.
Yep. See you then.
Bye bye.
Bye. All right.